So for problem 6, it says we have a function that gives the amount of rainfall in inches that have accumulated between midnight and t hours after midnight. And then it says, at what rate is the rain falling at 2:30 a.m.? So I'm interested in a rate of change in inches per hour. So I would need to compute f prime of t first, and then I'm going to plug in the value for 2:30 a.m. So it's going to be 1 over t plus 4 times the derivative of t plus 4, which is just 1, minus the derivative of natural log 4 is 0. And then if I plug in at 2:30 a.m., that will be when t equals 2.5. So f prime evaluated at 2.5 is equal to 1 over 2.5 plus 4, which is equal to approximately 0.1538 inches per hour. Courtney's velocity in miles per hour while running a marathon is given by the function y equals v of t, where t represents the number of hours, okay? Write a sentence explaining the meaning of this expression, v of t dt. So to think about this, we can think that I have a little velocity times a change in time. And I know that distance equals velocity times time. So what I'm doing here is I'm adding up distances traveled from 1 to 3 hours. So this is the distance traveled, or the change in distance traveled. From 1 to 3 hours. Next, it says a marathon is about 26.2 miles. Given that the integral below equals 26.2, write a sentence explaining the meaning of x in the context of the situation. So this 0 to x is the amount of time. So x is the amount of time. So x equals the number of hours that it takes for Courtney to run 26.2 miles. Okay, this one says a boat leaves a dock at 2:00 p.m. and travels due south at a speed of 20 kilometers per hour. At 2 p.m., another boat is 10 kilometers west of the same dock and approaches the dock heading due east at a speed of 10 kilometers per hour. At what time are the two boats closest together? So one thing to notice here is that it's asking at what time are the two boats closest together. So what kind of problem is this? This is asking for a minimum distance. So this is an optimization problem. And so what we want is we want the distance between the boats, and we want this in one variable. Okay, and so when I think about this, I have a dock and I have a boat traveling south. The speed is 20 kilometers per hour, so the distance between the dock and boat 1 will be given by 20t, where t is the number of hours. And then at 2:00 p.m., another boat is 10 kilometers west of the dock. And it's moving this direction. So this is going to be 10 minus 10t. So after t hours, it has moved closer to the dock. And then the last distance here is what we're going to call z, which is the distance between the two boats. So I know that z squared is going to equal 20t squared plus 10 minus 10t squared. And so if I go ahead and square that out, I'll get 400 t squared plus 100 minus 200t, plus 100t squared. And so that, if I simplify, that gives me 500t squared minus 200t plus 100. And then I know that z is the square root of that. Okay, and so now I have the distance between the boats written in terms of one variable. So now I'm going to take the derivative of that, set it equal to 0 to find a maximum. So z prime is going to be 1/2. Leave the inside alone. And then the times the derivative of the inside part, which will be 1,000 t minus 200. And so what is this z prime? This is equal to 1,000 t minus 200 divided by 2 square root of 500 t squared minus 200t plus 100. Because that negative 1/2 power is a square root on the bottom. So if that thing is equal to 0, basically that is equal to 0 whenever the top is equal to 0. And so if I set the top equal to 0, I get t equals 200 divided by 1,000, which is 0.2 hours. And so the question is, at what time are they closest together? So 0.2 hours, I'll do 0.2 times 60, and that gives me 12 minutes. So at 2:12, they're closest. Well, actually, I didn't decide if that's a minimum or a maximum, so I could double check and just check that it's a min. And on my z prime line, I can put in the 0.2, and I can check if it's greater than 0.2, I'll get a positive value, because if I plug in something bigger than 0.2, I'll get a positive thing. If I plug in something less than 0.2 here, I'll get something negative on top. So that means that z is decreasing and then z is increasing. So that is a minimum. Okay, so the first thing we want to think about is, so we have the clock's minute hand is 9 inches from the center. X and y represent the horizontal and vertical coordinates, the tip of the minute hand. Find the values of dx dt and dy dt when the exam ends. So let's think first of all about, okay, the clock is moving that way. So that means that the x value is a negative x value, but it's increasing because it's becoming more or coming closer to 0. So that means dx dt should be positive. The y coordinate is a positive y coordinate and it's getting bigger, so dy dt should be positive. And what about theta? Now, theta, we usually think of theta going this way, but we're talking about a clock. So the theta is actually shrinking. So that means d theta dt should be negative. Okay, so sometimes it helps when you're thinking about as things are moving in a picture, how are they moving and what quantities are getting bigger and what quantities are getting smaller. So that will just kind of help orient us to the problem. So I have dx dt, dy dt, and d theta dt. And so the hint here is to relate x, y, and theta. And so actually we can relate them separately. In this case, I know that hypotenuse is 9, and so I can say that sine of theta is equal to y over 9, and that cosine of theta is equal to x over 9. So in other words, 9 cosine theta equals x, and 9 sine theta equals y. So then I can take the derivative implicitly with respect to t. So I'll get 9 cosine theta d theta dt equals dy dt. And I'll get 9 times negative sine, so negative 9 sine theta d theta dt equals dx dt. Okay. So what I need to do now is I need to figure out what is theta at this point. So if I think about this, I know that this is pi. So pi is being divided into 6 equal pieces. And so 1, 2, 3, 4, 5 sixths of pi. So theta is equal to 5 pi over 6 in this instance. And my d theta dt would be the change in radians over change in time. I want my initial thing to be inches per hour, so my t I'm measuring in hours. So in 1 hour, the minute hand goes 2 pi radians. So 2 pi over 1 radians per hour is what I want to use for my d theta dt. Okay, so now, so that's kind of my first thought. This is what I need to plug in. Those are my 2 functions. So I can say now that dy dt is equal to 9 cosine 5 pi over 6 d theta dt, which is negative 2 pi. Oh, sorry, it's negative 2 pi, because remember we said d theta dt was negative. And then dx dt is equal to negative 9 sine of 5 pi over 6 times negative 2 pi. Okay, so dx dt should equal negative 9. Well, the negatives are going to cancel out. So 9 sine of 5 pi over 6 is 1/2. And then I have times 2 pi. So this is just equal to 9 pi inches per minute, per hour. And dy dt will be equal to 9 cosine of 5 pi over 6 is root 3 over 2 times negative 2 pi. Oh, sorry, it's negative root 3 over 2 times negative 2 pi. So dy dt is equal to, we'll get positive 9 square root of 3 times pi inches per hour.